And yeah, yeah, nice to meet everyone and share our learnings. And hopefully, we can exchange ideas, and I can take notes on how we can further improve what we are doing. So feel free to drop in your questions during the presentation as well. And it I I hope it is an open, and it can help us spark certain conversation that can lead to development in this particular sector. So uh, without further much ado, mm, let me share my screen. I think I'll have to share my entire screen, but okay. Okay. Can you see my screen?
Yeah, it's visible.
Okay. Okay, cool. So yeah, thanks again for inviting on presenting about the Ag-MCP. This is something that we have started building in at Digital Green in last few months. And as the name suggests, it is leveraging the model context protocol that has been introduced very recently in, I guess, in around February, March this year, which has taken the, the entire Gen AI and the LLM world. People have been building different kinds of MCP servers. Uh, and as the name suggests, the idea is to create an agriculture MCP enabled server, but it's not just MCP, it goes beyond that, leveraging agentic workflow. And the idea is to create open agriculture intelligence that can be used by everyone in the AgTech ecosystem, not just in India, but across globally. And today I'll try to go through the origin of how we stumbled on this particular problem, and what is the technical architecture, and what could be the potential that it can unlock. So uh, our journey so far. So a lot of my you might be aware about Digital Green. We are a not-for-profit organization. In last 18 years, we have been working in the field of strengthening agriculture extension systems through partnerships with various government agencies. Uh, and in this particular process, we have been building different software tools, most of them open source, open content, that have been leveraged by our partners. And our very latest flagship product is Farmer Chat, which is an AI-enabled uh, chat app where farmers can ask questions in a multilingual, multimodal way. They can ask in their own language through voice or image and get the responses. Farmer Chat has so far been downloaded more than 250,000 farmers across India and Ethiopia, Kenya, Nigeria. And it has catered to around 3 million plus queries. And one of the things that Farmer Chat had from the very beginning was a weather widget where the farmers can get a very quick view of what the weather is for today and the weather forecast for the coming week. And while this particular uh, uh, particular feature was something that our product team found to be very useful, and farmers actually require it, because agriculture is subject to the whims and fancies of what the weather forecast is, which is changing drastically. The entire calendar is getting shifted, and they need to know what the weather forecast would be. But one of the basic requirement that came out as we rolled out Farmer Chat was that the farmers need more of a actionable system where the weather based, it's not just the weather information that they want to consume, that this is the temperature, this is the humidity, or this is the chance of a rain, or this is the percentage in the rainfall that is going to happen. They want to use it based on their crop and what exactly they need to do. And while we try to solve this problem, the vision emerged that what we are trying to solve is not just limited to farmer chat itself, and it's not a unique problem. It's probably something that any AgTech company who is trying to work with the farmers, uh, even government systems, they can use it because this is dependent on the location and on the the APIs, the weather data that is available. And this led to sort of the problem became a slightly bigger in that frame when we started reimagining uh, of how we can decouple it from farmer chat itself. And essentially what it can solve is that it can lead to a lesser amount of duplicated development that goes on in very isolated, siloed approach by different organizations, where the teams that should be working more on engaging with the farmers, whatever service they are providing, they spend more time in trying to integrate the data and trying to create that intelligence system itself. What it also can probably solve is what we have seen on ground, that farmers typically don't just get the advisories from one system, or one channel itself. They get it from multiple platforms or multiple places. And if the input data is not same, the consistency of that advisory will not be same. This leads to an overall lack of trust by the farmers in not just one single, but the entire gamut of whatever the service providers are. It also means that it also can lead to integrating the delivery channels as well. So there are different delivery channels that serves different segments of farmers that can work. So not every farmer will have a smartphone and can download an app, or have for some places it will require an SMS or an IVR system. So the realization was that instead of what we are trying to develop and seeing it through the lens of a competitive advantage, we should look at it through the lens of building an open infrastructure that can be leveraged by any organization in agriculture domain. So this is what the architecture looks like. Uh, we are doing it in farmer chat. Sorry, I'm having some background noise. Uh, okay, so what happens in farmer chat is an architecture, which is where what we have done is when we started working on this was we have evaluated multiple weather APIs. There are different weather service providers. Not every weather service provider has the same level of accuracy and same level of granularity of data in every region. Uh, and it varies from not just national level, but also at a sub level kind of a thing. So there might be a service provider whose data would be more granular in a particular state, in a particular country than in another place. So we have to evaluate which whether service provider is best in terms of quality of data, in terms of consistency or reliability of the APIs, in terms of cost, and so on and so forth. Once we have the weather API, we integrated it with the agent, the AI agent, which basically takes the user information of that we have about our users in farmer chat. There are some users who have logged in and entered the crop in their profile, and I know what crop they are growing. Some users have not entered the crop. Some users have mentioned the crop in their conversations somewhere. Some have further given certain details about what when they have done a particular activity. So there's a rich amount of a user data that I can combine. And then based on that, I can create a very personalized kind of alert that can be served through the Farmer Chat app. Now, while this system works for Farmer Chat itself, the limitation that we see with this in terms of impact, because as a not-for-profit, our North Star being the reach and the adoption that the farmers have on ground, the reach is limited by our own ability to scale the app itself, which limits it to Digital Green's ability to reach as many farmers. The other part is that as the farmers use this, they can give certain feedback, and that feedback will further enhance that intelligence that is being built here. And that also remains limited or tied up with the reach that is there. So if I'm reaching 100 farmers, maybe 1 out of 100 farmers providing that kind of a feedback, and based on that particular feedback, I can improve further the intelligence that we are trying to build. And this means that my scale and my reach and my adoption is limited to this kind of siloed Farmer Chat app itself. And that is where we started reimagining as to what if we change it from a very tightly coupled kind of a system to an open system. And that led to what we are calling as Ag-MCP. So essentially, it's a three-layered architecture. The top layer is what we call what is the MCP server. Many of you would be aware about the MCP, but I'll just spend a few minutes here to uh, to explain why MCP and what it really does. So model context protocol that was released is essentially, a lot of people have drawn analogy between to a bridge. So LLM today can call an API and consume the data. Now, why the LLM needs to call the API? Because it doesn't have that real-time intelligence. So let's say weather or any other system. Now, for the LLM to call an API, it needs that the API must be written in a certain spec, which is the Open API spec. Now, not all the APIs are written with that particular approach, because when someone is developing the system, it is generally, you're serving for a particular business case, and that's not standardized. Although there is a standard that exists, it is not every API will be written as per those standards. So what MCPs does essentially is it converts those APIs, those external data, to the LLM in a way that LLM can talk to that particular data. So it essentially provides that bridge that can connect to all these APIs. And what it can do is, or what it enables is that I'm not now limited to just one weather service provider. I can configure it to multiple, or and it can depend on the region itself. So I can configure it based on, for India, I see that IMD API is the best, and I can integrate with the IMD API alone. Or if I want to have it, 3 APIs and want to poll, I can do that as well. The second layer is the AI alerting agent. I'll cover this in the next slide in more detail, but essentially what it does is, while the MCP server prepares the external data, enables LLM to talk to the external data, the agent actually makes sense of what that data is. So MCP is establishing a communication, and agent then makes sense of that communication that is happening, and essentially combining this information with LLM's own intelligence and reasoning ability to generate contextual and actionable insight, which then can be consumed by another agent. And this is where what we do is we change what we have in farmer chat as an agent which is taking the user data to something that is taking a region data. So essentially, from the user information in any system, we are taking the village or block or district level information, and based on that, I want to send and get that localized weather information. So instead of uh, you know user, I can have an a web agent which actually looks at what all geographic entities are there in that particular region. So let's say I've configured it for Bihar. What are the districts there in Bihar? What it calls another API to get the geocode, and then take that geocode and calls the weather API through the MCP server, and gets the weather information for those particular districts. So the agent now gets decoupled into two parts. One is a location aware rather than user aware, which generates the intelligence or the alert about just the crop and what will be the kind of alert that needs to be sent based on that particular location. And layer 3 is something which can be operated by the clients. And this is where the A2A protocol, the agent to agent protocol, comes into picture, where this layer 3 agent can be operated by any client, and they can consume the alert, which is location aware, and convert it based on the delivery of channel and their own user or their own business processes. So they may they may be serving farmers in a particular region which are growing particular crop, and they don't want to use the alert that is generated for a different crop. So all those business process plus the delivery channel, someone is serving through SMS, someone is serving through IVR base, someone is serving through WhatsApp, or maybe their own app. They take that, this agent takes that alert and converts it for that uh, particular user base and that particular delivery channel. And what it essentially does is it creates a channel agnosticism, and it enables a sort of composable intelligence that can be now be leveraged by everyone with a MCP server operating layer 1 and layer 2 as a server, and layer 3 a separate agent that can be installed by various agri service providers. Now, why is AI essential? Because and it's important to understand why we need to have an LLM based agent here. A lot of the agentic workflow that we are seeing, and a lot of startup ecosystem people are creating, they are essentially trying to automate the workflows that have already been there. And probably the role of AI is it enhances those workflows uh, where the workflow logic requires processing some amorphous kind of information. It's not a rule-based logic. So essentially, let's draw an analogy, or let's think of a system of a customer support. So if different customers are coming and they are raising a ticket, based on the category, I can decide the urgency, and based on that urgency, that can be delivered to the customer support team in their Slack channel or mailbox. Now, this was the old workflow that has been automated already. What AI does is it doesn't rely just on the category to decide the priority. It goes through the content of what is written to maybe decide the priority. And essentially, in this particular case, what we realized was that the information that we have to process is extremely complex, and it's kind of amorphous. It's not a straightforward lookup table. Like, for this crop, you do this. There are multiple crops in multiple regions. For those crops in those regions, for different varieties, the alert or the activity that a farmer needs to do on ground depends on the crop stage. The crop stage itself depends on what is the typical planting or sowing or a certain activity in that particular region. And that's a window itself. So, so let's say if I go in Bihar, uh, the paddy sowing season would be anywhere, from May to June first week, and it varies from district to district as well. So this information, which might be present in various documents, various kind of portals, is to be utilized, and there is some information or knowledge that is very standardized. Like, the information that is standardized is that if the paddy is in this particular stage in this particular month, and humidity is more than this, and there is a continuous rainfall for last 2 days, there is a chance of a pest, and this is the particular pest that or disease that can happen. Now that is a standard information, but whether the paddy is in that particular stage or not is not really is a very contextual information. uh, and that is where uh, the 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 AI works, where it combines and it understands what are the most prevalent crops in that particular region, what are the most prevalent sowing times and activities, and based on that, it comes up and gives the output of uh, the likelihood of a threshold of weather being more than what is desired, and that means a certain activity on monitoring that the farmer needs to do. So essentially, the agent basically takes in or consumes a structured information about the weather forecast in that particular region, and then decides what are the crop, what would be the kind of stage, and what could be the kind of action. So it is going to based on that particular stage itself. And this structured output is then can be consumed by the client agents, who can then convert it into or render it for the delivery channels that are there. So this structured output can then be converted in an SMS that there is heavy rain and you do this. So I want to limit it into a specific kind of characters. In a WhatsApp message, I may want to make it more contextual, richer kind of a thing. For IVR, I may want to use a further workflow where I create a voice note, which is then utilized in the IVR outgoing calls. Uh, Here is the demo link and the GitHub as well. So I've opened this particular demo link. So let's say I have this, uh, you know, we have, you can select a district of any district in Bihar. We have uh, instantiated for Bihar itself, and we can generate the weather alert. And what it does is it is then calling uh, the weather API in real time, and it gets this information that there is a high rain probability, and this is the expected rainfall. These are the important parameters, and there is an urgency of very high urgency that uh, there is a high rainfall, and these are the crops that will get affected, and this is the action that should be considered, that a farmer should think about delaying fertilizer application. They should be checking on the drainage. They should constantly monitor crops, and if they are into that harvesting kind of a thing, they start preparing for that. And this, when this structured alert that is created can be rendered for various channels in different ways, where we can have the text, in a markdown. The star denotes that it will be bold. This will be the title. There will be a payload button that can be integrated. We can also, these agents on the delivery side can also be uh, configured for a specific language, and so on. So uh, I would I would request everyone to go on this particular demo link, and can also look at the GitHub flow, GitHub repository, and how read through the markdown as to how it works, if interested. Now, why do we want to open source it, and what is the potential of it? As I said, our vision is that if we are able to open this intelligence for everyone, we can unlock a lot of network effects. The development velocity increases, the the consistency of the information that farmers get is much better through different channels. So imagine today, farmer chat is giving one information to X number of farmers, versus there might be something that is going through the SMS in a government channel, which may be different, or may not go altogether because of maybe some systemic issues. This essentially creates a kind of a uniform way. The other part is that, being an open source system, this can further be configured and can be run by anyone. So we can have a Bihar system, or we can have a Maharashtra system, or we can have a national level kind of a system, which can generate these alerts that can be used not just through one channel, but by any service provider as well. So the entire philosophy, create something which is composable in intelligence. It is channel agnostic. It makes it more farmer-centric, and it is something that is not just limited to a specific region. It is a globally relevant kind of architecture, or a system that can be created, which can work in different languages and different parts of globe. What are the next step that we are planning? We have created this Bihar weather server, and this is just taking the weather APIs. We intend to create similar kind of region-specific servers in Ethiopia, in Kenya, in Andhra Pradesh, and the regions where we are operating in. The next part is to integrate satellite imagery for getting the crop indices in those particular areas, and then also partner and get the soil level intelligence, and then take it to the pest and disease outbreak. So there are some global consortia of or global alliance of wheat rust, which is a major pest and disease that affects wheat crop globally. And the way the disease spreads is not through the political barrier, or political boundaries of a country. It depends on the weather patterns, and in terms of how it spreads. So those pest and disease outbreak, like a few years back, there was a locust outbreak, which I guess started in Somalia, entered Ethiopia, and it came all the way, crossed entire Middle East, and came all the way to the western parts of India as well. So those pest and disease outbreak, and the way it is spreading, can further be plugged in as and when it happens. And a lot of these pest and disease outbreaks that are happening are also associated with the climate change itself. What scientists believe that the locust outbreak is also related to global, the climate change, because of which the locust production sort of increased because of the temperature that were there. The idea is that these enhancements can benefit the entire ecosystem. It's not limited by farmer chat and just for digital green, and can also be taken further by different service provider or different organizations who want to integrate it with, let's say, market intelligence, or someone who is having IoT support, or operating the IoT based sensors. It can be configured and it can be used in different regions. So for developers, we have the GitHub repositories. For organizations, they can focus on serving the farmers. We want to also see if we can collaborate and enhance the knowledge base, which is right now in the agentic part. And there are obviously gaps that it is not available for all the crops for all the regions. But can it, we can find, as we roll out and as multiple organizations roll out, this feedback can further be given to the AI agent. And through that feedback, we also realize what are the knowledge gaps that are there, and the knowledge gaps that are already existing that we know can be improved over a period of time. And ultimately, it helps the farmers get this better intelligence, consistent alert at the right time. With that, thanks for uh, thanks for this time, and I'm happy to take any questions that you might have.
Thank you so much, Vineet. That was great. Before we invite Aditya and then we begin this question and answer session, John Wesley has asked on the chat for you to link the demo. You mentioned join us and like maybe try out the demo. If you have a link handy, feel free to add that. But that said, if anyone else has any questions, put them on the chat. But before we come to that, Aditya, over to you.
Yeah, thanks, Vineet. That was really insightful. I think some of the things I learned is somehow working parallelly on different projects, we arrived at similar solutions. For instance, in the weather implementation, I saw it's a very, very similar implementation in Vistar with the geocoding and a weather forecast. So that brings me to a question. Do you think there are some common best practices when designing MCP servers?
Common best practices. Okay. I think
Yeah.
I would just say the MCP server is really the easier part, I would say. And
Yeah, now it is. Yes.
yeah, I mean, it's really a low entry barrier. In fact, when
Correct.
MCP was released, I think way back in March or something,
Yes.
I started looking at it. I think it was Feb end of Feb, something like that. And it's really like you can go on Claude and you can
Yeah.
ask to write a code, and you can set up a MCP server very quickly. That's
Correct.
not an issue.
Correct.
In fact, our first MCP server that we thought of was, why not just create a weather-based MCP server? Because it's serving a lot of weather information from various places. But then I think when we combined it with the MCP server plus the agent, the MCP plus 2A, that is what I guess makes it much more powerful. Because
Correct.
essentially, let's say if I limit it to an MCP server that is providing me weather information from 4 different sources, I get those weather information. One is saying 31 degrees Celsius, one is saying 30.5, saying 32. I don't know which one is the correct one.
Which to be.
Right.
Well, I think in our experience also, we start like about 3 or 4 months ago, we tried our hand at MCP. It was really difficult. Today, like I think within a couple of days, essentially anybody can build if they have a proper agentic architecture. It's very easy to build an MCP.
Yeah.
What one question on that? See, tools, the tools that we defined on top of which, on top of APIs, the descriptions, the arguments, they flow back to any agent that we're designing, right? What we have noticed, and perhaps if you have a different experience as well, Vineet, please let me know, is when we're using a client as powerful as Claude, as powerful as GPT, even badly designed tools, they pass through. You'll never notice the problems there. But when you're working with, let's say, an open source model where tool reliability is difficult to maintain, we found it challenging, and we had to work more on the tool layer, on the tooling, on the MCP layer, instead of the client layer. Right? So, do you think there is some sort of quality mechanism at place there that we can look into, so that we can perhaps confidently say, hey, this will work with these sorts of clients. This will work for models like Claude, for GPT. It may not work for a Llama 8 billion model, right? Something of that sort.
Uh, yeah. So I think the the critical part is when we are talking about the tool itself is I think the more difficult part is the error handling and validation.
Okay.
Also the other part is about the I would say the async operations and the connection pooling. So it's more of an
Nice.
engineering issue. I would say that we encountered when we started integrating. Uh, if if we are taking an API and creating a tool definition, in terms of defining that tool definition itself, the the best part, or it is very important to give a proper description as to what it does. So if I just say that this is a weather forecast tool, it is not sufficient. You have to be very specific that it is a weather forecast tool that will take a give a for a particular date range and for latitude, longitude. So those kind of a tool description with the clear schema that is there works quite well with both, I would say, GPT or Claude. We tried out, in fact, we were thinking of having a cloud client as well, Claude client as well. So both, I would say, the proprietary models like GPT and Claude, they they're pretty very they're able to call those tools if given the tool description well. The problem that happens is in the error handling and validation, and that is something that is dependent on the API itself. So if I have an API which is giving me a good long CSV file as an output, then I have to, those and there could be different error scenarios. That is where it becomes a bit tricky. So I think the best thing is to work with those APIs at least, which are reliable enough, which provide that information, and that error handling is actually very well defined. Like you know that these would
Yeah.
be scenarios
Yeah.
can happen, that
So
easy to,
yeah.
because I think the important part is LLMs are good for you know for non-deterministic or
Yeah.
outputs. If you want a deterministic calculation, a very deterministic kind of a thing, it is better to take it outside the LLM itself.
Yeah.
And if we let LLM sort of try to understand what could be the error and what it needs to do and create a lot of chain of thought, it can go wrong, and there could be multiple kind of scenarios, and we are opening it up. So I would say there is still an important part of selecting the tools, the APIs itself, describing that, and that is where the code base comes into picture. because that will help. And I guess as we are having this conversation, I guess we can publish a best practice kind of a thing along with the
Yeah.
in the GitHub
I think that
repository.
would be useful. I think that would be useful. See, one thing we've learned actually on precisely this problem is, and we learned it the hard way when we migrated from using GPTs to smaller models, open source models, is that tool definitions need to be as simple as possible. Like I can give it the latitude and the longitude to a weather forecast tool. Beyond that, we should really think about restricting it to as few arguments as possible. Right? Do you really need a day's parameter? Do you need to sort of pre-configure a 7-day forecast? Right? So I think that sort of thing really helped us have more reliability when it came to smaller models. And this problem is really hidden, I feel, until you start adopting smaller and smaller models. Then you see that maybe more work needs to be done on the tool side. Right?
Yeah.
Yeah. So another question, you mentioned that when farmers log in, they have some data configured. They can essentially uh, put in their crop, put in their location, any other details. Is there a way that you know of that, or some practice around handling this data, especially perhaps PII data that may be involved? Because as long as you're in charge of the application, you can maintain that. But then it makes the question about reusability of the tool when other PII data might be involved.
Yeah, so so that is what the heart of the entire the why we created that Ag-MCP kind of a thing. Within Farmer Chat, just like any other app, there's a sign up flow, there's a the login flow itself. And with that, they are sort of prompted where they can, enter their crop so that we can serve them the best possible, the starter questions that they can ask. But as it happens, most of the farmers would skip that particular, like we don't fill our profile in on the LinkedIn as well. So, so people just skip that particular part. Now, this is a user information. Uh, what we are what we are trying to do here is, and the agent part with the MCP server, like this particular example of Bihar, we are saying that, hey, the LLM has enough information, and if I ask what are the most prevalent crops in a particular region, it knows the prevalent crops. So we are saying that instead of
One,
getting,
just as an example to what you mentioned, like you mentioned, we are looking to planning to integrate soil health information, like a
yeah,
report, let's
yeah,
say. So, how would you design that sort of API? Would it be an API where a farmer can enter essentially to the agent and an ID, their report ID, or their farmer ID, or something of that sort?
yeah, I would say so. I would separate that particular concern on the client side, right?
Client side. Okay, that makes
Because
sense.
because let's say the soil parameters today, if I enter a location, and it might not be my own location, I enter
Correct. Exactly.
and we
Yes.
we have a module in Ethiopia where CGIR labs, they have developed uh, a soil site specific fertilizer recommendation module. Essentially, they have a model through which they can estimate the soil acidity, which is a critical parameter based on which the fertilizer has to be applied. Now, if I enter a location, a coordinate, just like I can get the weather for this coordinate, or I can get the geo code for or reverse geocode, I get the soil, the fertilizer recommendation. Now, what we are trying to separate the concern here is on the MCP server side, I have this tool that is configured. I know, the village names, and I can also divide it into various sections because I can also see, the soil parameters are not changing in a across this particular kind of, area. So what I can do is I can say that this particular place has this kind of an acidity or this kind of soil parameters. This information, when combined with the the weather information that is there, gives me a very rich kind of an alert as to what should be done. So if I know that a particular nutrient is missing in the soil, based on the soil parameters that might be available through the satellite imagery, or and the accuracy of that, we are not going into that particular, that's an entire different discussion altogether. But what we are trying to say is that these are environmental APIs or whatever. These are location aware intelligence. And I know that this location, this particular region, these are the crops. This is likely the kind of date. This would be the stage, and these are the parameters. And this is what
So,
the
yeah,
farmer.
that information becomes like semi-personal or generalized. But what if there is a personal data, right? What if I want to know the status of some scheme or my report of my soil health that I don't want anybody else to see? Do you think that should not be on the MCP, or is there a way to add some authentication or some security around the MCP tooling? Because we're
Uh,
also looking into that. We've not found any very, very good solutions, at least. Uh,
yeah, I haven't, we haven't thought about that particular use case, but my very first reaction would be that the personal data, we are sort of separating it out. There is no MCP
Close
involved.
to MCP. Okay.
That is in the third layer. That is on the
Mm,
client side. So client
mm,
is simply getting that in this particular village or in this particular block, these are for this particular crop, the farmers growing
mm,
this particular crop need to monitor or see the signs of pest. Now, whether it doesn't know till this point who the
mm,
farmer is, right? Now that is where it is on the agent side and
mm,
the client side, and the client
mm,
who operates that agent, and they
mm,
the reason that they would want to operate an agent, and it is not really necessary even, they can consume this alert and they can
mm,
combine with their own logic in their own system, because that's a information that they have. There is a it will become, it always becomes, legally as well as business wise,
mm.
it is not advisable that the user information is given,
Faster. Yes.
passed on,
Correct.
right?
Correct.
So what
Correct.
it is doing is, the entire architecture and the philosophy is that you have this environmental or these APIs or these tools that are there, and you create based on that, for those particular region, what could be the actionable things that the farmers can do.
Mm,
And this is sort of broadcasted,
mm,
and various clients can then consume this. They
mm,
can configure their own business process. They
mm,
have got an agent if they want to render
mm,
it for a delivery channel. If they don't want to operate an agent, that's also fine.
mm. Yeah.
But
Yeah.
what they get is that so one company may be operating and they might be just be serving wheat farmers, and the alert is for the paddy farmers. It's fine for them. They're not concerned about it.
What
But they
I'm also interested in is, like these Gmail, GitHub connectors, they're also in a way similar because they have very personal data involved. But through authentication, etc., they are still able to release those MCP servers. Perhaps if a similar thing can be done for schemes, for any personal data for agriculture at a central level, let's say, that would be really useful for others to consume. Well, we have Aadhaar, which is essentially still taking in some personal data, but not passing it through any. It's done in a very non-critical way. So
Yeah,
perhaps for MCP as well.
yeah. So there, if I'm so essentially the GitHub connector or the Google connectors that are there, they're relying on the authentication of
Oh,
that
yes.
ID that they have created. So if I have let's say, in Agri Stack or something, if I have a
Good
farmer
idea.
and I have a
Yes.
single sign-on kind of a system, right? or I have a auth layer. So if I want to combine it with an identity layer, I can authenticate. Then definitely, based on certain, after that authentication, that information can be sent across through the network by the client themselves. So then, yes, I think it can become a very pull-based kind of a thing. What we have is a more of a push-based, that there is a server that I have set up, which can generate these alerts and all those kind of things for a particular region. But then we are hopeful that some people would be interested in consuming this. In that case, what happens is it becomes a very pull-based kind of a system. If there is an authentication layer on top of some sort of a farmer ID or
Yeah.
identity.
I'm going to
Issue. Sorry. Yeah. Go ahead.
I'm
Namrata.
going to pause you here just in the interest of time. Maybe we can come to the
Yes.
final question after we take some of them on the chat. The first question we have is, how can NGOs deploy it?
Yeah, I mean, it is so there are two ways we are thinking about. One is that we have an MCP server that is configured, and we can configure it for different regions, and people can have those agents that they can just configure at their end and consume it. The other is they can run that entire thing on their own instance. uh, we'll be happy to provide assistance, and that's why having it open source on GitHub is so that anyone can use it and can modify and as required. But if there is some sort of an assistance that is required, we'll feel free to connect. We'll be happy to help as well.
Super.
From what I've seen in the documentation, it seems very easy. Vineet. It's a very well done job, actually.
Yeah, thanks.
We have the next question is actually, do we really need an agent to orchestrate data retrieval APIs? We can have a simple application that can invoke the various data sourcing APIs and compile it, and then pass to agent for more interferencing. What's the rationale for an agent?
Yeah, we don't need an agent to call the API. It's the agent's main work is to consume that and to process that. So uh, the data, if I look at it, maybe I can share my screen maybe to just explain some part here. Can you see my screen?
Yeah.
So this is what it looks like, a crop weather calendar, right? What it says, and this is an LLM can't understand this particular image. What it says is that this is my duration. These are various stages. This is where bacterial blight happens. This is where sheath blight happens. This is where something else happens. This is the kind of temperature that will happen. This is likely the month where it will happen. So these are the kind of temperature ranges and humidity where the prevalence of these kind of disease or these kind of occurrences is very high. And essentially, if I have to process this information, so this is present in multiple docs and so on. And this is what is the knowledge that the agent is actually trying to process, which is that likely based on today's date, we are in August, the likely thing is that this is the stage of the crop, and these are the kind of the pest and disease that can happen. And these pest and disease happen for these threshold. And for this threshold, if there is a weather forecast, so the API calling is just one part. That's an input from where we get what is the weather forecast or weather in next few days. But then it has to be combined to process that there is indeed a chance of something, and then combine it as to what the action that needs to be done, taken by the farmers. And the action may be as simple as just monitor your crops. So it's like, we send an alert like file your income tax before the due date, right? If you have not already done. So this is what the agent is really doing. And that's why the AI is required, because creating this kind of a giant lookup table for different districts, for different crops, for all the cases is sort of quite challenging and impossible in a way.
Vineet, actually, I have to interrupt you there. There was a correction in the question. Apparently, it was for the 3 layers you had shown in your presentation. One
Yep.
was more related to retrieving variety of the environmental data. That was the context for the question, apparently. I'm just correcting what was on the chat. That's it.
Okay, so sorry, can you repeat it
So the
again?
question of why do you need an agent was not to what you were sharing, but
Okay.
more to the point of the 3 layers that you had shown.
Okay.
Context of that layer, it seems.
Yeah. Sorry. So Vineet, I asked the question. Like I was seeing that you had 3 layers, right? Layer 1 was hitting all the APIs, pulling a lot of data. Now APIs typically return a JSON object, so they already are written very standardized objects, right? So why do you need an agent to orchestrate those workflows? You might as well have a simple conventional database, have a simple application, pull all the data, compile the data before you pass it to layer 2, which could be more like an agent. That was the question. So I was trying to understand what was your rationale for having an agentic interface even at the layer 1.
The layer 1 is not exactly the agentic interface. The layer 1 is more of a tooling thing where it is where the MCP is working. So essentially what MCP is doing is that it can enable me to an agent. So it is preparing those APIs in the form of tools so that it can be consumed by any agent. That is the layer 2. Now, I can very well, call the APIs and store all the data as well, and then also, the agent can consume. So it can be that can also be done. But typically, it will be a kind of a real-time scenario based on the date that we are operating. But the layer 1 is not really the agentic part. It's I would say tooling part. So it is preparing those APIs to be actually be talkable for the agent. If I
Okay.
If I may also come in on this, the utility of tooling is beyond just fetching the data as well. I think it's also about narrowing and making sure that scope is maintained. If you all have heard of that Replit incident recently, where on Replit, a developer was talking to an agent which deleted all the database, which
Yeah.
means essentially, as a coding agent, that agent had access to an unrestricted tool where it could run any query or any code in an unrestricted way. The idea of tooling is to make sure that it cannot just call any API it wants or any database it wants.
Yeah.
Sure. No, that's clear. Like, because you are referring to, if I remember you're referring to layer 1 as agent number 1, which then passes to layer 2, which is agent number 2. So it was in that context I asked. Like, okay, if it is tooling and if it's fine, then I get it. Thank you.
Okay. We're also 3 minutes past our time, so I'm going to give the last question a chance, and then, of course, closing statement from both Vineet and Aditya. If the conversation is very interesting, we'll come back to you, Vineet, on another session, and of course, with Aditya. The last question on the chat was, could you please share examples of some of the amorphous sources of data?
Oh yeah, I just shared that particular PDF itself. So there is one of the ICAR organization, CRIDA, one can go. They are creating crop weather calendars, and it is extremely in India, it is an extremely challenging. Once you see those crop weather calendar, you realize that India is really diversity that we see in terms of not just people, but the amount of, you know, the vegetation that we have. So that is one source of data. Similarly, I think there are certain other sources globally in US FDA and I think in Europe as well. And some of this information is there in the government extension handbooks as well in various countries. But I would say for India specific, CRIDA is the best place. I can share that particular link post this session. And I
Okay,
think, yeah, I think Ram just was asked that particular question. So he is one of those expert who's who's from the agriculture domain and knows the agriculture and the technology side both. He can point out to some other domain, places as well. Like we have worked with AgriSat and CEAT, CGIR labs. They also have tons of such information, but it's a bit fragmented based on geography, I would say.
super. I will, of course, take closing thoughts from both of you. Maybe one thing just to praise you, someone has asked, is there a SPOC that they can connect to for any doubts and further information related to use case development? So if you could put that on the chat for Nikhil Gupta, that would be great. On that note, any closing thoughts from you?
Yeah, thanks for this opportunity. And yeah, really enjoyed the conversations and the kind of things that came out. Specifically, I think one of the takeaways for me was the identity-based kind of integration that can be done. Probably making it a more pull-based rather than a push-based kind of a system that is there right now.
Aditya, any closing thoughts from your end?
Oh, thanks, Amrita. Thanks, Vineet. I think we need a longer conversation sometime soon. I think I'm very keen on exploring if a Vistar MCP and a Farmer-Chat MCP, the Ag-MCP can also be integrated, and we can see some interoperability there between two MCP servers. That would be very useful.
And
I'll
also holding you to the best practices on GitHub. You know, it came up very early on.
We should do that.
That's a very valid thing. I mean, I think as these AI tools are evolving. In fact, I was having this conversation with my colleague today morning itself that we are doing a lot of vibe coding ourselves, and that example of Replit that Aditya gave, there has to be some best practices around vibe coding. Same way there are new best, so they're not best practices of coding itself, coding tools, but we need to develop those best practices of prompting of these kind of tools. That's a good input. We should definitely add in that README there, and happy to collaborate on the Vistar and stuff there. We'll be very glad if something can be built on top of it. It's all there in public domain. Fork it and use it.
All right. Thank you very much. And for all the folks who stayed 8 minutes overtime also, thank you so much. Appreciate time. Thank you. Have a very nice evening.
Thank you. See you. Bye.